Hello guys, welcome to task 8.1 code explanation. So in this task we will look at our bank program. We will discuss about how the program is working, and then we will also look at the key concepts that we have covered in this object oriented programming, such as polymorphism, inheritance, abstraction, etc. So let's get started. Bank program. We have created a program which acts as a bank, and it will give you certain options such as withdraw money, deposit money, print balance, add new account, print transaction history, and quit. So basically in this program it will act as a bank, and user can choose the options, you choose the options between them, and then can perform their actions. So here in this slide, you can see that the program is running totally fine. So over here, basically what happens is user can choose between the options from 1 to 7. So let's say if you want to, do a transfer transaction or anything, or if you want to create an account, you can just choose an option, and then it will show you all the details that you need to add. And in this way, basically our program is working. So it takes the information from the user, and then it runs accordingly. Object-oriented programming concepts. In this program, we have used various object-oriented programming concepts in order to make the code more efficient and effective, such as abstraction, polymorphism, encapsulation, and inheritance. So the main idea to use this concept is to, make the code more effective, because what happens is, like, let's say when we work on a very big code, or when we work in an industrial code, they all use these kind of concepts so that they can make their code smaller. There is lesser lines of code, and it's effective and doing the same work. So that's the main idea behind all these concepts. So firstly, let's look at an abstraction. So abstraction is the concept of object-oriented programming that shows only essential attributes and hide unnecessary information. The keyword abstraction is used before the class or method to declare the class or method as an abstract. The abstraction modifier can be used with indexes, events, and properties. So here is an example of our code. So if you look at another example, so here transaction class, so it's an abstract. So we have used abstraction. So transaction class in an abstract. So if you look next to the public, so after public we have written abstract, so which basically indicates that this is an abstract class. And when the compiler is running the code, these keywords, compiler pick up these keywords, and compiler exactly know that this is an abstract class. So in this way we use abstraction in our code. Encapsulation is referred to as a mechanism of restricting the direct access to some components of an object, such that user cannot access state values of the variables of a particular object. Encapsulation can be used to hide both data members and data functions or method associated with an instantaneous class or object. So here is our example. So in this example, we can see that we have written private account and to account. So this is actually our field, and at the bottom, whatever like you can see as a private, so those all are our fields. So we declare these fields so that we can have kind of a controlled access. So the main idea to do that is to make our code more secure, because let's consider an example. So let's say if you are a user, users should not be able to change their account balance according to themselves. Like they cannot like just type in their amount according to themselves. There should be some kind of filtration process, or limited access should be given to the users. So due to all those concepts, we use encapsulation. So it basically gives a controlled access, so that when you are coding, you can have a better understanding what are privates, what access am I given, do I have a get or do I have a set, all those concepts. So that's why we use this concept. Inheritance. So inheritance is a very popular concept. It is a key feature of an object-oriented programming. We can create new classes from the existing class. The class from which a new class is created is known as a base class, parent or superclass, and the class which is derived is called the derived class. The derived class inherits the field and a method of a base class. It helps with the code reusability in C#. Let's look at an example in our code. So over here, you can see like our parent class, which is the transaction class, and we have a derived class, which is the transfer transaction class. So transfer transaction class is derived from transaction class. So in order to put this all together, let me give you a simple example. So let's say, let's take an example of a family. So in family, we have mother and father, and children inherit the features of mother and father. Let's say if a father has a blue eye, then children also inherited blue eyes as well. So the same concept is applied over here. So in the inheritance, what happens is parent derived class inherits all the methods, functions, and field from the parent class. So in this way, we use this concept to decrease the code duplication, that we don't have to write all those methods again and again. Derived class can straight away get all those methods from the parent class. That's why we use this. Now let's talk about polymorphism. Polymorphism in C# is the ability of objects of different types to provide a unique interface for different implementations of method. It is usually used in context of late binding, where the behavior of an object to respond to a call to its method member is determined based on object type at runtime. Polymorphism enable redefining methods in derived classes. Polymorphism form one of the most fundamental concept of object-oriented programming, along with encapsulation and inheritance. Inheritance let us inherit field and methods from other class. Polymorphism use those methods to perform different tasks. This allows us to perform a single action in different ways. So in order to put this thing in a simplest form, you can think as a polymorphism, it is kind of a thing which can be appeared in all different forms. So let's consider an example of a woman. So woman can be a mother, woman can be a sister, woman can be a wife, woman can be so all these roles are played by the same woman, right? So this is so it is like the simplest example that I can give you for polymorphism. So in the next slide, we will look at the example as well to get you a better understanding. So as you remembered earlier, the transfer class is the parent class and the transfer transaction class is the derived class, right? So in the transfer class, we have a public void, public virtual void execute method, right? And the same method, like if you look at the contents of the method, the method's contents has been changed. So over here in the transfer class, we have used virtual. However, on the transfer transaction class, we have used override, and with help of this, we were able to change the content of the same method. So that's why this concept is very powerful, that you don't have to create methods again and again. You can just use the same method and then you can change the content, and it will behave accordingly. So that's why it's really powerful concept. And I think that's it for me. Thanks a lot for listening. So this was Gautam Bedi, 217-508-259 student ID. Thanks a lot, guys. Have a lovely day.